compressor. How does your robot get that name?
So somebody at one point made a comment during the competition that compressor doesn't dance. And true to spec, actually, our robot shouldn't dance. And it's a techno song with that name. He's an artist. And yeah, that's pretty much it. So actually, at the start, you may think, Leanne, if you press start. Anyway, it takes some slight calibration time. I'm pretty sure every team here is using a noisy gyro. And it takes about a 5-second calibration time. Oh, but it seems to have already gone. So we're, like everybody else, doing a basic wall follow mode. You can see up there on the bot client, there's a big cyan bar. Now it's red because it's in ball acquisition mode. That means that it goes for the balls. Cyan, which is a rough shade of blue, I'm told, is used for just the generic wander mode. And then when it's yellow, it should go towards the goal. One slight problem that a lot of teams have had, including ourselves, is that we get stuck an awful lot. Like you can see it now, we have shaft encoders, which are measuring the number of ticks that each of the wheels make, and we've got a thread constantly monitoring. Have those changed? And if so, if not, it should hopefully back up, though it seems like it's running into a bit of trouble now. I'm not entirely sure why. If the wheels are spinning, that will fail. And it's currently in wander mode. Anyway, sorry.
So I know that you've done some fairly sophisticated things with your image processing. Can you tell the audience at a high level what your image processing does?
Actually, I can't because I didn't code it.
There's a thing in their wiki that says 9 nested for loops! Exclamation! Which is now removed.
If you've taken 6001, you know why recursion is useful. Some people don't know why recursion is useful despite their heritage. And so we at one point had 9 nested for loops to go through a 3-dimensional cube. So it hasn't moved.
Do you think you're stuck at this point?
Well, we're pretty clearly are stuck. Whether or not the robot knows that is a slightly... Yeah, well, we're declaring it dead, unfortunately. We think our shaft encoders are probably broken.
The team thinks is the issue is that one of the LEDs may have snapped off of the shaft encoder. So the team is going to look into that. Team 8. Oh, 2. So what you're about to see here from Team 8 is probably the most interesting looking robot once it shows up. But would you like to start talking about the mechanical design of your robot?
Our robot is different from most of the other, actually all of the other robots, because instead of having 2 wheels and a differential drive, it has 3 wheels, and they're oriented around a circle, so it can go in any direction that it wants to without having to turn or anything like that. So it helps us from getting stuck, which you should see soon when we start it up. If it hits a wall or gets into a bad situation, it'll just try some other angles and it'll just take itself right out of there by going in a completely different direction.
Now, it might not be entirely clear to people in the audience how this set of three-wheel configuration actually works. So could you describe, for example, if you just want to drive forward, how would you do that using three wheels?
Well, one of the simplest cases that you can imagine with three wheels, if you look up there, you see they're at 120 degrees from each other. So if you wanted to drive directly over one of the wheels, you could run the other two at full speed, and the sideways components of the motion would cancel out, like it's doing right now, and only the forward component of the motion would be remaining, and it'll go in that direction.
What's it doing right now?
Right now, it's wandering around. It's hitting things and getting stuck, and then determining that it is stuck, and as you see, backing up from it. It should be looking for balls and finding them, and we'll know soon if it is.
It's kind of moving towards that red ball. Did it notice that the red ball was there?
We had some problems with thresholds and I think it might be having problems determining what is a ball. I think right now it's having a problem determining what is a ball because the thresholds, we thought we had them right, but they're slightly different from the thresholds for the test field. So now it's probably just going to search forever.
Now your camera is also spinning around as your robot moves. What's the purpose of that?
We decided if we were going to go for the three-wheeled, go in every direction approach, the main reason to do that is so that if we saw something interesting or decided we were stuck, we could just choose a different direction and go that way. And we thought that was a lot more useful if we could look every direction as well and get more of an idea of where interesting things might be in relation to our robot. So the camera can also turn 360 degrees, and because it's on a servo, it always knows which direction it's facing, which doesn't help us too much if it doesn't know what a ball is.
As you were driving towards that wall, there's some red lights that come and shine up onto the wall. What are those doing?
The red light is actually just the LED from an optical mouse that's underneath the robot. It's on the bottom. It's sort of spring-loaded into the ground, so it's always pressing nice and hard against the ground. And the optical mouse we liked because it has really high resolution. It's a ready-made package, and it already interfaces with the computer. So that was actually a pretty neat thing to get that running. And since it does have good accuracy, the calibration's not very good, but we don't care about the absolute measurement very much. We care more about the relative measurement. So it can draw the map any size it wants to as long as the map is accurate. And so that's what it's doing right now. That's why it's been it's avoiding areas where it's been before fairly well. But like I said, it is having a problem determining what objects that it can see are balls. It's actually dropping, if you will, it's dropping breadcrumbs behind it so that it knows where its breadcrumbs are in relation to itself, and it can say, no, I've already been there before, I want something new, and it's trying to find new areas.
So as we can see here, it's finding a new area in which to explore. Although their image processing isn't quite working right now, they did try some pretty sophisticated things. Would you like to talk about that?
Yeah, some of the we did some research into some common different methods of analyzing images, and we're using a couple of different algorithms in the pictures, but you don't get to see them because it didn't find any balls. But what it's doing is it's finding areas where things change a lot, as in where blue changes to white, red changes to blue, red changes to white, any of those things. And it's able to trace around those and find edges. And so that's what it's been doing the whole time, although it never found any red pixels.